Thanks again for the introduction. Hi everyone, it's great to be here. So today I'll be talking about more focused segmentation tools that we have in OHIF and Cornerstone 3D library. So OHIF, as Dr. Harris mentioned, is a zero footprint application, and Cornerstone 3D is a library that's kind of powering the rendering and tooling. I've been working with OHIF and Cornerstone for more than 4 years now, and 2 years of that, maybe more than 2 years, has been at the lead architect at this role. All right, let's get into that. So basically, uh, when we're thinking about segmentation, usually our mind goes through the definition that it's basically classifying pixels in an image, whether it's organs, tumors, or other anatomical regions. But the main question that should be asked is what actually constitutes the segmentation. Are we only talking about label maps and pixels that we assign our ones and zeros, or we're dealing with contours and points that defines a boundary, or maybe we're talking about the surface models, the polygons that we have seen being shown in the volume rendering. As we all know, each of these approaches have different applications. So a couple of years ago, during the redesign of the Cornerstone 3D, from the library that we now call Legacy Cornerstone, so we had to rethink the segmentation as well. So we looked around and found a concept called polymorph segmentation that was pioneered by our friends and colleagues at 3D Slicer. So polymorph segmentation is basically the concept that let you have multiple representation of the same structure, like a label map, but you can have a contour representation and a 3D surface representation, as I'm showing on the right in the images. All of them are managed within a single object. The key advantage here is there are automatic conversion between representations using conversion graphs. So there is no need to redo all the manual reprocessing of the data again. So we saw that there's already a ton of VTK C++ code that Slicer team has written, and it exists for the polyseg. But the question was, how do we bring it to the web? Because our stack is web-based, and web is completely different than the code that's written in C++. So that's where we turn into WebAssembly and web workers to basically prevent us from reinventing the wheel and just use those two technologies to cross-compile the C++ code for the web browser. So 2 years ago, we partnered with the XNet team from Institute of Cancer Research London because they were looking for the same thing. There was some requirements for them to turn label maps into surfaces, and together we wrote the polyseg WASM library. That's open source. You can find on that link on the bottom left. That makes me, it reminds me that I haven't sent the slide links. So I just sent it to the chat because my slide have some videos that you might want to look at your own resolution compared to network streaming. So we cross-compiled all the converters, and we saw we can achieve near a kind of native performance while still running them in the browser. So now I would like to go over my slides to showcase the current capabilities of OHIF. My slides usually have a video, but on the top there is a try demo. If you click on it, that just goes through the exact same page with the exact same data and hanging protocol for you to explore. So if I start my demoing here, so you can see that here we are creating a new label map segmentation in OHIF. We are using our brush tools, which are supporting 2D and 3D brushes. We also have erasers in 2D and 3D. There are threshold tools that basically either let you pick a range and do segmentation in label map, or it's basically a dynamic that will probably get shown next, and it picks the threshold based on the center. So that's very easy for organ segmentation. As you can see, all of our segmentation tools can interact in any plane. So axial, sagittal, coronal, oblique. So all of our tools work. And a little bit further, I'm showing our shape tools. So here I'm drawing like a big sphere. And in a moment, I will switch the layout to a 3D primary. And that's where exactly the polymorph segmentation kicks in. You can see the interactivity of the 3D viewport while we're going, and there is a notification on the bottom right that says I'm processing a 3D conversion to surfaces. So all of that is done in real time on the user device without blocking the UI. So we convert label maps into meshes and polygons using our WebAssembly converters and run it in a web worker, so that we make sure the UI remains responsive. As I said, this is a web browser environment, not a full-fledged desktop environment. So there are limitations in terms of JavaScript is single-threaded. You can't compute a heavy task on a single thread. You need to offload it. So all of this is OHIF Viewer with the current segmentation capabilities. But as I mentioned, we have a Cornerstone 3D library that's usually ahead of OHIF, because when we want to bring the features into OHIF, we need to have certain considerations, like we need to do interviews with the users, we need to consider the system integration, overall architecture, UI and UX. That's a big part of it. So usually our Cornerstone 3D library regarding features are ahead. So what I'm going to show you next is something that we recently merged, which is about label map interpolation. As you can see, it's not inside OHIF, but it's a Cornerstone. So the bulk of work is done, and we are finalizing and iterating our final steps to merge that into OHIF. So the demo is I fill 2 slices, skip a couple of slides, and when I press the keyboard shortcut, it fills them based on the morphology of the segmentation object. All of that happening again using WebAssembly, using ITK, WebAssembly morphological filters in the browser. So there is no server involved for all of these. And the good thing, as you can see, is it works in any plane. So I can have 2 slides here, and then I just understand based on the morphology of what to interpolate. So let's now talk about contour rendering, because sometimes that makes more sense to represent the segmentation as, because it's more efficient than label maps if we think about it. In label maps, we allocate memory for each voxel, but for contours, basically just the 3D points along the boundary of the segmentation. So we know that in certain applications, as Dr. Harris said, in radiation therapy, for RT structure set, contour-based segmentation is commonly used. So next, I would like to show you the RT structure set rendering that we have. So this is a study that has RT structure set. When the user double clicks on it, it instantly understands the contour, use the contour representation that we have, and overlays them on the referenced image. We have configurations regarding borders, other aspects regarding filling, opacity, and also we have some jump to contour animations that some of our users really like. In addition to this, which is our basic rendering for RT structure set, we have developed a freehand segmentation tool, so that you can just freehand use your hand to draw a contour. This is not a label map. This is just following the contour points. And after that, you can simply drag and edit. We have merge operators. So if you start a mesh from inside, that will append to the contour, and if you want to use it as eraser, you can just start from outside and we will erase that. Again, all the configurations regarding opacity, colors, borderlines are there for contours, and we are able to render in any planes as well. So here is a acquisition plane on the left axial, and then on the right we are seeing we are drawing on the sagittal. So next, I want to introduce our spline-based contour segmentation. You can see it predicts the next point if you place it, and it predicts the path based on the spline basis functions. We have done a lot of research about how different design systems such as Adobe implemented splines, and we ended up at this nice preview for the paths of splines. So you can have different basis functions. I guess this is using catmull ROM. We have also implemented the B-spline. So you can put breakpoints, control points for B-spline, and contour is getting created. You can see it's smoother as the B-spline, otherwise it usually are. Again, same configuration regarding your border thickness and alpha opacity is there for you to try. So now let's talk about a little bit more about GPU accelerated segmentation tools. Because I explained about our basic fundamental tools like brushes and erasers and splines, but traditional image processing algorithms, for example, GrowCut, still have their place. Users like them. They want to use them to put seeds, as you can see on the top image, for different segments, and then they run it, and the GrowCut does grow from those seeds and fill the gaps. The bad news is these are computationally expensive. It's very much for impossible for large data sets. So what we have utilized is web GPU, which is the next frontier for GPU computing on the web. You can think of it as a modern replacement for WebGL. So we are moving off WebGL rendering completely, and the new standard is WebGPU. And during the design of WebGPU, they have taken into account our kind of medical imaging use cases that we sometimes don't need rendering. We have computation that we want to offload to GPUs. So that's the great news about WebGPU, that we don't need to do much hacks to have a pipeline move to GPU. So here I'm showing you our simple GrowCut example. Again, you can try it on top. I'm putting a couple of seeds, and you can see after I run the GrowCut, basically around 3 or 4 seconds, it does a full body over 150 slices GrowCut. And it is super fast because it's taking advantage of GPU parallelization. We wrote it from scratch in WGSL, which is the programming language for WebGPU. I think we were the first one in the world to have implemented that in WebGPU because we couldn't find any other implementation. But the good news is we didn't stop here just to give the users a WebGPU manual GrowCut. We built a framework around it. That means that users could write their own custom tools to apply certain pre-processing and then offload it to our WebGPU GrowCut implementation. We have one of those tools implemented for the community to get inspired. It's called a one-click segmentation tool. It's called Region Segment Plus. Again, you can try the demo on top. So during the demo, you can see when the click happens, it automatically detects the negative seeds for the GrowCut by looking at the vicinity of the click and finding a threshold to define a negative seed for it. And it is super fast because it's entirely on the GPU of the device. There is no server here. Everything is in the browser. You can turn off the internet and still use all of these GPU accelerated codes. So far we've looked into fundamentals of segmentation tools, and then later we looked at some GPU GrowCut based implementation that we have. So I'm going to talk next about AI-driven segmentation and what tools and capabilities we have in this area. So one important aim for us has been always to try to make OHIF Viewer as lightweight, modular, and extensible as possible. So that means we want to limit the amount of backend components that you have and you need to run OHIF Viewer with, which at the moment is zero. You don't need a backend to run OHIF Viewer. So focusing on the front end aspect and focusing on the imaging workflow, segmentation, RT, it makes us explore other opportunities with other groups. And we did a collaboration with MONAI team, which is from NVIDIA, to be able to write OHIF version 3 plugin for them. So you can see that here. So first of all, for those who are not familiar, I guess everyone knows MONAI by now, but this open source AI framework for medical imaging, they have a lot of models. I guess Vista is their newest model, and you can see it got connected to the MONAI server, and it fetched the latest models that the server has, and you can see that after run, the data is sent to the backend, which is a MONAI server backend hosted somewhere that has access to GPU. And then when the labeling is done, it sends back the segmentation as Nifty, and we just render them in OHIF. And then you can see OHIF is extensible enough that you can integrate our segmentation tools on top of the, let's say, MONAI label plugin, so that if fine-tunings is required, the user can perform that. There are other modes for MONAI. There is active learning, which is a human in the loop that's also supported in the plugin. And it's great. Having a server for MONAI, you can connect your OHIF and take advantage of all the advanced AI models on your data. So MONAI solution, as I said, is great, but it requires to maintain a server, meaning that you have to deploy it somewhere. That server has to access to one of the NVIDIA GPUs, most probably. You need to set up an infrastructure, handling of authentication between server and front end. It is sometimes painful, but sometimes it's required. The model is huge enough that you can avoid that. For complex scenarios, you can avoid that. But in another use cases, sometimes we don't need the full complexity. We just need the AI assistance that helps just with the segmentation. So that's where our client-side AI segmentation comes in. This is our newest addition to the segmentation stack tools that we have. The model is by Meta. So it's a segment anything model. It's an encoder decoder model. And as you know, it is not written for the web. So again, using tools such as ONNX runtime that runs on the web GPU, we were able to compile the model weights for the web. And that means that the segmentation happens on your browser. Again, you can turn off the network. It will work. There is no need for any external GPUs. Your browser, if you have any laptop post 2020 would handle that. So we have currently three tools: a marker include, a marker exclude, and a box prompt. So here I'm showing you again the demo. I can see I put a marker include that initiates a prompt to the segment anything model that's running in the browser. The model comes back with a preview. You can take a look at that. You can accept the preview or you can reject the preview. So that's about including. And I guess sometime later I'm showing the example for excluding. So for example, here the model came up with this prediction, and then I put another marker include, the model goes off. Then I switch to marker exclude that other area, and then the model came back in the line. So we have marker include and exclude for prompting the AI, and something else that we have is using the prior knowledge from the previous slice for the next slice. So whenever you see a preview getting accepted, it doesn't show here, but I'm hitting a keyboard key N, certainly that's configurable, and it goes automatically to the next slice, and it just does the segmentation itself. That's because we sample from the previous slice points and use it for prompting to the next slice. That's something that we have worked on, and I think our people, the users would love it. And finally, there is a box prompt aspect that, as you have guessed, is you draw a box. Again, everything is happening in the browser. There is no need for external servers or backends. Again, the hitting of the N moves and samples from the previous slice for the next slice prediction, and the user can accept or reject or edit the segmentations. We recently released OHIF Viewer 3.9. You can see the release summary on the right. For 3.10, which is planned for the end of first quarter 2025, we would like to reduce the gap about all the new and shiny features I introduced in Cornerstone and bring it to OHIF. Hopefully we can refine the UI and UX to make the most sense of it, to integrate it into our OHIF workflow. I didn't even show the tool history that we have because of the time, but we have also undo redo for segmentation and annotations and all of that. So hopefully the 3.10 would be reducing the gap for the technology that we have in Cornerstone and the viewer that we have at OHIF. Thank you for your time. Couple of resources. If you visit ohif.org, there is a mailing list you can subscribe. You can join our Slack that has over 1,000 members right now. And if you would like to get connected, ask questions or any collaboration opportunities, our email is here. Thank you.